Analysis of programming languages for artificial intelligence. Group members.
History of AI. 1956. John McCarthy coins phrase artificial intelligence. 1952 to 1962. Arthur Samuel writes the first AI game program to challenge a world champion in part due to learning. 1950s to 1960s. Masterman establishes AI at Cambridge, creates semantic nets that do machine translation. 1961. James Slagle writes first symbolic integrator sent to solve calculus problems. 1963. Thomas Evans writes Analogy, which solves analogy problems like the ones on IQ tests. 1965. J. Robinson invents resolution method using formal logic as its representation language. 1965. Joseph Weizenbaum creates ELIZA, one of the earliest chatterbots. 1967. Feigenbaum establishes AI Create Dendral, the first useful knowledge-based agent that interpreted mass spectrographs. 1969. Shake, the robot combines movement, perception and problem solving. 1985. Alvin, an autonomous land vehicle in a neutral network, navigates across the country 2,800 miles. Early 1990s. Gary Tesaro creates TD Gammon, a learning backgammon agent that vies with championship players. 1997. Deep Blue defeats Garry Kasparov. 5th century BC. Aristotle invents syllogistic logic, the first formal deductive reasoning system. 16th century AD. Rabbi Lowe supposedly invents the golem, an artificial man made out of clay. 17th century. Descartes proposes animals are machines and found a scientific paradigm that will dominate for 250 years. Pascal creates the first mechanical calculator in 1642. 18th century. Wolfgang von Kempelen invents fake chess-playing machine, the Turk. 19th century. George Boole creates binary algebra to represent law of thought. Charles Babbage and Lady Lovelace developed sophisticated programmable mechanical computers, precursor to modern electronic computers. 20th century. Carol Capek writes Rossum's Universal Robots, coining the English word robot. Warren McCulloch and Walter Pitts law partial groundwork for neutral networks. Turing writes Computing Machinery and Intelligence proposal of Turing test.
AI languages. We'll be talking about two AI languages, Prolog and Lisp. Prolog. What is Prolog? Prolog is a logic-based language. That is, Prolog is presented with a set of facts, rules and goals, and it attempts to prove that the goals are true by applying the rules to the facts. Prolog is a declarative language. A declarative language defines what the problem is using the language of logic. Execution is not in the step-by-step manner. Here we tell the computer what we know about some people, and then we can ask some questions from the computer. Is someone tall? Is Kamal fair? Is Sumana beautiful? What we tell the computer are facts, and what we ask are questions. Prolog characteristics. Knowledge is represented by facts and rules. The system applies logical deduction to find answers for the problem. Prolog programs. Elements of a Prolog program. Predicate. A predicate defines a relationship among elements or properties of elements. Here is an example. Mother xy. This could mean x is the mother of y. Large 6 4. This could mean 6 is larger than 4. Sentence. A Prolog program consists of sentences, and each sentence terminates with a full stop. Non-empty head sentence is called a clause. Clause. Prolog clauses are of three types: facts, rules, queries by users, or goals. Facts. Facts represent what is assumed to be true, or things that we know. They do not contain variables, Now here are some facts. Color red, company IBM, course CSC3230, fundamentals of AI. Here's the meaning of that structure. If H is true, then B1, B2 up to Bn are all true. Goals. As we said before, goals are the questions that we ask from the computer. Merely a special kind of term, distinguished only by the context in which it appears, functor of the goal identifier what predicate the goal is for. For example, teacher Kamal could mean, is Kamal a teacher? Here is a prologue example. Have a look at it and enjoy. Explanation. In the domain section we have declared two variables, namely child and age. In the predicate section we have declared a predicate called player, and in the close section we've given some facts. Here we say Peter is a player and his age is 9. Paul is a player, his age is 10. Chris is also a player, his age is 9, and Susan is a player, his age is also 9. And in the goal section we ask a question. The question is, list all the players who are 9 years old.
How does Prolog work? The following video will demonstrate how a Prolog program works.
Hi guys, I'm putting on my TA hat now and giving some hints for this homework assignment that I gave. And yeah, this is obviously not going to make any sense at all unless you've been following along in the Pomodoro Complexity using Prolog series. So here goes. Okay, some early feedback from the very brave people who are trying to do the homework problem that I just assigned indicates that I left out a very important concept. I really hate these. Actually, I have a love-hate relationship with these 10-minute video links. Your time is important, and so it's really good to try to squeeze these things down in 10 minutes, but sometimes I squeeze too hard, and I leave out important concepts. There's a very important concept that I should have covered. But before that, let's talk a little bit about how to do this homework here. Let's make a sample genealogy here. Okay, so let's make the first generation here. We got, we'll make the patriarch of the family, great grandpappy, and he begat grandpappy. All right, and grandpappy begat daddy, my father. And then, of course, daddy begat me. Right? Alright. So this is a sample genealogy here, right? Okay. So let me demonstrate some stuff here. Okay. So let me try to do the uncle using only begats. Okay. So first of all, if I say begat, father, me, right? I get my dad, right? So then going from my father, I can get to my grandfather, right? So now, who's my uncle, right? My uncle would be these sons of the grandfather who aren't my father, right? But you don't know how to do that yet. The best you can do is this. Now, okay, so basically, I've gone from me to my father, and I've gone from my father to my grandfather. Then I've gone back down the tree from my grandfather to my uncle. But here's the problem, right? Let me hit the button. Uncle equals daddy. So this is just wrong, right? a very important concept of the uncle is the uncle is somebody who really isn't your daddy, right? So this one works. There's like multiple solutions here. This one works, but the daddy one is wrong, okay? So here's how you get rid of that. Okay, I left this one out. It's a very important concept. Okay, so the objectivists here will appreciate this one. A equals A, right? So the equal operator in prolog basically succeeds if both of these guys are equal. Right? That's fine. But you don't need that. What you need is an operator which will succeed when both of them are not equal. Right? And that's this one here. The slash. Okay, this one says yes if both of those are not equal. It says no if both of those are equal. Right? A is equal to A, so this one fails. Right? Now using this, we can do the uncle, right? So we do the same thing. We go to the father, we go to the grandfather, we go down to the uncle, right? And then we also specify the father has to be unequal to the uncle, right? Now this works, okay? My father equals daddy, my grandfather equals grandpappy, my uncle equals crazy Uncle Albert, and we hit the semicolon, no more answers, okay? So I left out this very important concept. Okay, now there's another thing which is puzzling some people here. Let me put some other cases. All right, say I have a silly younger brother and a bully older brother. Beats me up every once in a while, right? Let's compile this. Now, it's kind of disturbing, but here's the score, right? Say we do, we got me, we get my silly younger brother, we get my bully older brother. Now, here's the score, right? If I want to do that, I'll just giving up the ghost here a little bit, but I'm just going to daddy. Here's the problem, right? Kid equals me and sibling equals me. Well, I've got to be different from my sibling, right? And I get all these solutions that are here, right? What's going on here? I'm getting way multiple solutions. Well, these multiple solutions, don't be bothered by these multiple solutions. These multiple solutions actually, okay, first one, you got to get rid of this one, right? Okay, and it's pretty easy to guess how to do that, given that I just showed you it's not equal to, right? But the rest of these ones that are here, don't be bothered by them. Basically, here's the score, right? Think about all the different ways that you could prove that my silly younger brother is, my sibling. First of all, I could find his father and my father and prove that those two people are the same. Or I could find his mother and my mother and prove those two are the same. This kind of stuff, right? So, Prolog will give you one solution for each possible way that it can prove something. And often there's more ways of proving things than what you might suspect. Okay? So, these two things are really what you need, and which I really left out of the previous one to do this one. First of all, this all-important operator, right? And second of all, don't be scared of multiple solutions, or if you get the same thing two different ways. Take the moral to heart. There's often more than one way to prove something. There's more than one way to skin a cat, as they say. All right? Good luck on the homeworks. I'm thinking about, you have plenty of time to do it. I'm thinking about putting up the solutions sometime probably after Wednesday or later. So you have plenty of time to do it. Please send me an email if you